So our objectives here today, we want to learn the basics. We want to talk a little bit about chemistry, finish and appearance, surface and pre-treatment systems. We want to spend a little bit of time talking about that. That's certainly a critical step that sometimes is missed and overlooked. And then certainly application of powder coatings. How does it work? Why does it work? And then we want to talk about, after everything is done, you want some sort of assurance that what you've done is going to be an effective coating. So we want to talk some about quality assurances and some things that we can do to make sure that that quality is looked after. And then we'll finish off the presentation with some questions. So if you've got questions as we go along, if you want to write them down, certainly we can go back, and I'll try and leave ample time at the end of the presentation so that we can get some good dialogue between us. So what are powder coatings? First of all, let me ask you a question. How many of you folks powder coat? Do all of you powder coat? How many of you are thinking about powder coat? Okay, all right. And then how many folks specify powder coating? You basically put on a drawing. Okay, so there's a little bit of a mix from everybody. Are you all smaller job shop operations, or okay, fantastic. So some of this, you're likely to know a lot of this, you're likely to know some of this, and some of it may be, an interesting way to look at things. Maybe it's a little bit of a challenge to you to think in a little bit of a different way when you think about powder coatings in the application. So obviously powder coatings, they're free-flowing, they're dry powder. For those of you that are coming out of liquid, there are no VOCs, there are no hazardous chemicals associated with powder coatings. In most jurisdictions, you have to check with your jurisdictions, but it's so it's so environmentally friendly, you don't even have to report that you're throwing it away. So it can go directly to your landfill. You do want to check with your local municipalities and make sure that they are in agreement with that. But in general, there's nothing really to worry about with powder coatings. So very environmentally friendly. Typically, it's applied electrostatically. So there's a powder unit. The powder passes from the box or from the hopper up through a mechanism that conveys the powder to the gun. It goes across an electrode. You put a negative charge on that powder, or there's an ion sphere in essence. The powder then is attracted to a grounded part. You roll that part into the oven after the powder coating is applied, and that's where the cross-linking takes place, where the curing takes place. Typically, powders can be cured most of the time is between 375 and 400 degrees, but it can be, in special instances, special formulations, maybe even as low as 325 degrees. Those are not standard products. They are usually products that are cured at temperatures below 375. They're typically described as low energy cure products. They're typically not available off the shelf, and again, they're custom made for a specific application and a specific part. So there's some technology involved in making a low energy coating. There are two types of polymers that are used in powder coating, or resin systems that are used. There's thermosetting and thermoplastic. The difference is this: thermosetting only melts once. After that, the only thing that happens is it begins to degrade and become ash. So you can heat it up all you want. All it's going to do is continue to degrade and become ash. Thermoplastics, on the other hand, can be remelted. So if you think about thermoplastics, and an example of thermoplastic would be PVC. So you've all seen PVC coatings on park benches and trash cans and things like that. That actually can be, if they were to pull it out of the oven and notice something wrong, they could actually put that back in the oven, it would become sort of liquefied once again. And that's the difference between the two coatings. And there are reasons why most of the powder coatings that you see are only thermal set as opposed to thermoplastic. Thermal setting, or rather thermoplastic powder coatings, they have a very they're forgiving in that they're very flexible. You can apply them at very heavy film builds. The drawback is they're either, if they're durable, and by durable I mean they won't chalk and fade in the sunlight. If they're durable, they tend to be very expensive. If they're kind of your traditional functional thermoplastic coatings, like a PVC coating that would go on a trash can or whatnot, that kind of rubberized coating that you can sometimes see, it's not very durable in the sunlight, so it wouldn't be very good for architectural components that were going to be outside of the building in general. So why powder coatings versus liquid? In essence, just to give you the nuts and bolts of it, as I explained earlier, powder coatings are extremely environmental. The average material efficiency, you can reclaim powder coating so you can get up to 95% efficiency. There's a considerably lower applied cost compared to liquid coatings where powder coatings are concerned. Negligible VOCs are emitted during the curing process. So much so that it's a very small percentage in relation. It's almost undetectable. And it only happens during the curing stage. So powder turns to liquid. There's a little bit of a VOC that's sort of gassed off there as the powder is liquefied. And that's it. You can't smell it. You can't sense it in the atmosphere. It's a very, very small component. Single coats, you can apply, in general, single coats, you're going to get double the coating thickness by comparison to the average liquid coating with a single coat. It has excellent mechanical properties in comparison to most, and I always caution folks, let's not oversell the product. To most liquids, it has excellent mechanical properties in comparison. You get very good edge coverage, excellent. You can get very good metallic effects with powder coatings as you can with liquid. And it's well established in Europe, and it's growing here as regulations tighten up a little bit here in the United States. The biggest consideration as far as efficiency is concerned, if you're running a shop, the biggest consideration is essentially you have no dry time. As soon as that part is cool, you can package it and you can ship it. So you can save some. I know in the aerospace business, the specifications can get rather insane. They're primarily liquid, and these folks complain about it quite a bit because it's 8 days to apply a liquid aerospace and defense coating for one of the prime contractors that are in the industry. So if you think about that, it's 8 days. It's 7 different painting steps. So it's paint it, dry it, set it in your warehouse for a day or two, bring it back. It's an arduous process. So powder coating, the advantage of powder coating, and this is what we're selling to the defense industry. Apply the powder coating, cure it. As soon as it's cool, put it on the truck and get it out of your shop. So powder coating is well established in Europe. It's the majority of the business, and it's slowly but surely it's turning that direction. In North America as well. What does the typical powder coating process look like? I'm not a big fan of this graph. There's a flaw in this graph. I'll talk about it a little bit, and then I'll see if anybody can pick up on what the flaw is. But in general, what you do is your production basically runs in a circle. So you prepare the part, you hang the part, you pre-treat the part, you coat the part, and you cure the part, and then you unload it at the end of that circle. and ship it out the door. Anybody pick up on what the flaw is with this graph?
Can't come back to research.
Anybody? No, I mean, that's pretty typical. You have to do any part to go around after inspection. Yes, sir?
Pre-baking?
Pre-baking?
Preheating the material?
Preheating the material? No, but that's a good one. You're on the right track. I'm going to give it away because we're short on time. If you notice after pre-treatment, what happens after pre-treatment? You got to dry the part. So there's they neglected to put a dry off of it in the loop on this graph, but nonetheless, it's a fairly good graph. It kind of explains what that process circle for powder coating looks like. How is powder coating manufactured? And we'll go through each of these just so that you're kind of aware of what you're looking at. On the top left, you're looking at powder coatings that are coming out of the extruder, as well as the picture on the bottom left. In the middle, powder coating is, as it comes out of the extruder, it's spread out over a cooling sheet where it's cooled. And then there on the right, you can see it's pulverized into chips first. It's broken into chips first, and then it goes through a mill and a classifier, and then you get your final ground powder. So we'll talk about each of those steps and which steps are important to you as you kind of consider which powder coatings you're going to use. The first step in creating a powder coating is we need to talk about a formulation. The formulation is done in the lab, and it's based upon descriptions that either you would give to the laboratory or your sales rep would give to the laboratory that says, I want a coating system that will achieve this function. And then within that, there's a number of questions that can be answered, and from that, you can create a powder coating formulation. Once the formulation is established, you would go to dry mixing or dry blending, and basically, if you think about it, they got a big stainless steel bowl in the shop. They weigh out all of the materials. They would put it in there, and they would mix it up so that it was somewhat, generally speaking, a homogeneous blend of all of those components that would go into it. Once it was pre-mixed or blended, it would be brought over to the extruder. Within the extruder typically has, depending on the type of extruder, it'll have a heating element, and then it'll have screws that'll sort of put those components under pressure, and then as well blend them as it moves through the barrel of the extruder, and then that extrusion process obviously. It's important because it makes sure that we have a nice homogeneous blend. So from the front end of the first box to the tail end of the last box of the production, you have basically the same color, same characteristics, all of those sort of things. So that's the key in extruding. Following the extruder, the product is ground. It's kind of a funky looking machine. It almost looks like a big gearbox where powder is sort of injected into it. The powder chips are sort of injected into it, and then by centrifugal force, those chips are pounded and pulverized against the side of this big steel grinder. And then from there, it goes through a screening because obviously powder coating charges. The optimum particle size for powder coating to charge is somewhere 25 to 35 microns. So obviously if you got, and it won't charge if it's below 10 microns, let's say, or 4 microns. Well, obviously you want to deliver, we as a powder coating manufacturer, we want to deliver good product to you. So we want to manage that particle size for that powder coating to make sure that the majority of that powder coating in that box is within the range. And that's what screening does. Certainly it can take out some of the, if there's a fiber or a hair or something that's picked up in the process, that screening process will pull that out as well. But the main process of screening is to make sure that the powder that's put in the package is of the right size to charge. And then after all of that is said and done, through the packaging process at Tiger at least, at various points through that packaging process, powder is actually pulled out of the package and panels are sprayed, and there's a variety of quality assurance testing that is done throughout the manufacturing process. So it may be, I don't know, if it's a small run, it may be every other box that they're looking at a panel. If it's a large run, it may be, you know, for the first 10 boxes, they'll look at every other box, and then it's every 10 boxes from that point in time. But the key point is, all the way through, there are quality assurance steps that are taken throughout the manufacturing process. What does that system look like? In graph form, if you start on the upper left-hand corner, you can see where basically powder coating, four elements: pigments, hardeners, resins, and additives. Those are weighed in. It's put into the scales, obviously. It's dry blended. The premix is then fed, lower left-hand corner. The premix is fed into the extruder. From there it goes up the chill belt or across the chill belt, and then into the grinder, the sieve, and then finally into packaging at the lower left-hand corner. So that's kind of the manufacturing process for powder coating. Let's talk a little bit about chemistry. Chemistry obviously is important. If you're wanting to achieve a certain mechanical requirement or a certain performance requirement, you have to consider chemistry. Sure. So, powder coatings, as I mentioned here in the last slide, it's primarily four components. It's resins, it's pigments, it's additives.
Can you speak to that mic by chance?
Yes, sir. Thank you. That's a little better, isn't it?
Yeah.
My apologies. So it's basically four components. It's resins, it's fillers, it's pigments, and it's additives. So you can see there's a bunch of additives that go into powder coating. The majority of the powder coating, however, is going to be resin and a little bit of pigment. Everything else is in fractions of percentage points within the formulation. So what are the primary or most typical types of powder coating chemistries that are available in the marketplace? Fluoropolymers are what I would describe as a hyper-durable coating. It would be for aluminum extrusions and aluminum facades, for example, on high-rise complexes. It's a very expensive coating, but it also has a very good rating as far as durability is concerned. It's comparable to liquid Kynar or powder coatings, Kynar formulations as far as its durability. So we would describe a fluoropolymer product, for example, as a 15-year South Florida product, which sounds great. We go, we want to put that on our fence and railing, but not so quick. It's not so good if you handle it and touch it all the time. So it's not quite as mechanically durable as other options that are available. But that's kind of top of the heap as far as durability is concerned. Super durable polyesters, I'm sure that you've all heard about super durable polyesters. In general, the industry looks at a super durable polyester and they say, well, that's a 5-year South Florida coating. And what does that mean? It means that it will hold the majority of its color and gloss when applied, properly cured in South Florida for 5 years. So I think it's 60% of gloss, and I think it depends on the color as far as what the allowable color shift is concerned. But are you folks aware of NOMMA? You ever heard of NOMMA? So NOMMA has ratings for those powder coatings. Following the super durable polyesters, most of you have worked with, and I'm I'm sure you're well familiar with polyester powder coatings. It's kind of the workhorse in powder coatings. It has very good mechanical properties. It's very, pricing-wise, it's very competitive. It's easy to apply. There's not much to worry about where polyester powder coatings are concerned. It's very good for exterior environments, and it looks good, good enough to use as an interior application as well. Super durable polyester urethanes is a little bit of those are a little less seen in the marketplace. They're a little more uncommon, but they're out there. Polyester urethanes, polyester epoxies, the hybrids. You folks have heard of hybrids. Then there are acrylics, which are primarily used in the automotive industry. Polyester acrylic hybrids are out there. And then epoxies. So those are the primary types of powder coating chemistries that are available to the industry. When we look at what's possible and why would we choose one resin formulation over another, starting with fluoropolymers, well, yeah, it has the best UV resistance. It has pretty good chemical resistance, but its mechanical resistance, again, is poor. So that's why you wouldn't use that on fence and rail. Polyesters, on the other hand, well, why is that such an attractive or useful resin system within the industry? Well, you can get a wide range of color and glosses. It has good UV resistance. It has pretty good chemical resistance. It has pretty good mechanical resistance. And generally speaking, it has pretty good UV stability. So when you stick it outdoors in most places, in the Midwest, for example, you might get 5 years before you really start to notice a color shift or some fade, maybe longer depending on what the environment is. Finish and appearance, obviously, depending on the formulation, you can get a wide variety of finishes and textures and appearance. So there's a wide range of solid colors from lusterless, which is essentially 1 to 3 units of gloss, all the way up to full gloss, which is 100 units of gloss. There's a full range of, I think Tiger has 800 and some odd standard products that we offer to our customers. So most of those, the majority of those, are solid color products. Metallic effects, there's a wide range of effects, and there's a wide range of textures that you can get. So smooth hammer tones, varied textures, varied appearances, some that are, they look like a paint, and some look like an automotive finish. So there's a wide variety that's possible where metallic coatings are concerned, and that's growing. Textures, everything from smooth, ultrafine, fine, to river and orange peel effects. So, pre-treatment and surface prep. I had mentioned earlier that pre-treatment and surface preparation is a vital component for achieving a successful powder coating job. A lot of times folks kind of overlook the pre-treatment step in their process, and to be honest with you, it may be the most important step. So my little statement there, don't put lipstick on a pig, it really, that's a great way to sort of remind yourself, hey, pre-treatment is a very, very important step in what we do. So,
Can you give them my little statement on it? We don't paint the substrate, pre-treatment.
thank you, Keith, that's an excellent point. You don't paint the substrate, you paint the pre-treatment. So, it's a very important step. There are 2 steps to it, to pre-treatment and surface prep. So there's cleaning. You can use a chemical solvent to remove dirts and oils. And then there's also mechanical soil removal. That would be we're sandblasting, for example, or soda blasting, or there's a number of different medias that you can use to blast. The conversion coatings, second step in that cleaning and pre-treating process, they're organic chemistries that are applied to the substrate, surface. What those conversion coatings do, first of all, they're an excellent substrate to powder coat over, because you're not powder coating on the substrate, you're powder coating on top of the pre-treatment. They're an excellent substrate to powder coat over. They enhance adhesion, number one. Number two, they create a crystalline structure over the top of the substrate, okay, over the top of the metal that you're coating. And what happens then is if you have powder coating that is damaged, or you have a coating system that is damaged during installation, after installation, during some point in the life of the component, basically what that crystalline structure does is it helps to slow down the undercutting of corrosion underneath the paint. So you folks that are doing fence and railing, you see blisters all the time. What's happening there is you may or may not have a good pre-treatment system underneath that that's keeping the corrosion from undercutting quite so rapidly underneath the paint. Chemical surface preparations, they typically include the following stages, and there's 4 of them, generally speaking. So there's cleaning and degreasing. Obviously you want to get the salts and oils and contaminants off the surface. There's a chemical etching step, which if you think about the chemical etching step, it's just like when you were to sandblast or soda blast a part, you're mechanically etching a part. Well, there's a way to do that chemically. It can either be acid or alkaline based, but it's part of that process. Then you apply your conversion coatings. The most typical conversion coating, and there are a number of conversion coatings that are out there, but the most typical conversion coating that you would see on the market, or if you were to have a chemical rep pre-treatment salesman come in, he's going to probably talk to you first and foremost about iron phosphate. That's an example of what a conversion coating could be. Hexavalent chrome is another. Most folks don't have that. Hexavalent chrome, if you think back to the movie Aaron Brockovich, that's the touchstone for those of us in the coating business. They were trying to use an excellent pre-treatment or an excellent conversion coating, hexavalent chromium, to protect water towers. The problem is hexavalent chrome obviously is a carcinogen. It's poisonous for human consumption. So that's kind of the touchstone for us. That's what a conversion coating is. And then certainly throughout that process, in between that process, you would have freshwater rinses. A word about rinses. It's important at least that your final rinse be very clean water. If possible, if you can swing it, if possible, I would recommend a deionized water rinse as your final rinse. You'd be surprised. Those solids that are in city water or in well water or in water that's provided to your shop, you'd be surprised on the architectural side of things where aluminum is concerned, architectural aluminum. When we test systems that have city water rinses as their final rinse and versus a DI water rinse as their final rinse, guess what? City water rinses at the end of it's as though there were no pre-treatment system or conversion coating put down whatsoever on aluminum over 2,000 hours. It'll corrode almost immediately. On the other hand, if you were to take the final rinse, and even if it were just a halo rinse, so a misting rinse of deionized water, it removes enough of those solids that you get passing results for corrosion. Pre-treatment systems, they're one step in the process, but as you're seeing here, it's a very important step. Mechanical cleaning and etching, by contrast, obviously sandblasting or soda blasting. The one thing that I would say, it's an excellent cleaning step. Obviously, there's no conversion coating with sandblasting. It's an excellent cleaning step, provided it's done correctly and effectively. You do want to take some care that you're not impinging impurities into the substrate. So, but aside from that, it's an excellent cleaning step. So, obviously, if you're dealing with steel, you're going to want to go, and primarily sandblasting is done on steel. You can blast aluminum. I probably wouldn't use sand in those instances, and depending on the thickness of the metal, you'll want to be careful that you don't deform it. But primarily speaking, sandblasting or soda blasting is used on ferrous substrates. You should achieve a near white metal profile. So that means you've removed all the dirts, oils, and mill scale. Okay? Cleaning the surface using solvent rags. I know a lot of us, and I've done it in shops that I've worked in myself prior to powder coating. Using a solvent rag, it's the most risky and ineffective method for cleaning surface prior to painting. Obviously, there's no conversion coating there, but it doesn't remove the oxide layers. It really doesn't remove dirt and oil. It just kind of spreads it around. If you think about it this way, that your cleaning operation is only going to be as clean as the solvent that you're using and the rag that you're using. So if you think about steel, and you're going to clean a section of steel with a rag, after 2, 3, 4 inches, guess what? You now have a dirty rag. You're no longer removing, you're just spreading it around. So you go to your solvent bucket, you rinse off your rag, now you've contaminated your solvent. You can see as you go through this process, sometimes it's the only thing that you have at your disposal, and obviously you should use it if it's the only thing at your disposal, but just a word about it, it's a really ineffective and inefficient way to clean it apart. But if that's what you got, that's what you got. The application of powder coating. So how does the equipment work? How does the process work? And I particularly like this graph. I like this graph because it talks about the 2 different types of charging that can be applied to powder coating. Tribostatic spraying is a little bit old technology. There are a handful of tribo guns that are still out there. There is a manufacturer, I think Wagner has a system right now that they're promoting to the marketplace. It's a box-fed unit. You can switch back and forth between tribo and electrostatic. Tribostatic powder coating compared to electrostatic, which is electrostatic, obviously, that's the new kid on the block. That's the latest and greatest technology. The advantage to tribostatic powder coating is it's pretty good in the Faraday areas or into those tight corners. So it's very difficult to get powder coating up into those sort of hidden areas or in those corners. Well, what tribo coating does is tribo coating basically as the powder moves through the application equipment, it scrapes off electrons. So you get a positively charged ion cloud, if you will. Well, it's almost line of sight, but it will do a little bit of a better job in some instances in getting powder into those Faraday areas or into those corners or crevices or difficult areas to get powder coating into. So up in here, that would be a good example of a Faraday area. Lots of metal surface. Excuse me. When you think about a charged powder, the first thing that it wants to do just by the laws of physics and nature is it wants to be it wants to be neutrally charged. It wants to be grounded. That's why it's attracted to the grounded part. So the closer you get to the metal, the more that powder wants to grab a hold of. So when you think about a charged powder particle coming up into that cavity, if you will, it's very difficult to get powder to apply up in there and get it collected up in there. Sometimes on occasion, I've been told that tribostatic powders will do a better job of that. So that's basically what's the difference between those two technologies. The application equipment that's used, obviously, it can be anything from a small booth, which you see spraying red powder there on the left, and this picture is actually, it's kind of hard to determine exactly what's going on here. I lose my note. There it is. This, up on your upper right-hand corner there, with all of the automated guns, that is going to be a vertical architectural aluminum line. So line speeds are very, very fast. There's a number of guns that are applying coating. And then obviously what most of us are used to seeing when we have a small project, obviously we're going to use a handheld box bed unit. So you should, as a general rule, you should apply your powder coating immediately after cleaning and preparation. The longer that part sits around, the more contaminants are going to settle on it and the more potential you would have for contamination. So the typical question that I would get would be, well, you say right after. Well, how soon is right after? If I clean the part on Friday, can I still apply powder coating on Monday morning? Yeah, you probably can do that, but I probably wouldn't advise it if you went beyond 12 hours. If you go beyond 12 hours, you're starting to ask for some problems. So you're going to get some flash rust, maybe if the substrate wasn't completely dry for pre-treating. So as a general rule, if you're going to pre-treat something, get it coated within 12 hours. So if it's, if you pre-treat it at the end of the shift, you want to coat it first thing in the morning. So, but beyond that, it doesn't hurt running that through cleaning and pre-treating one more time if it goes beyond 12 hours. So if you want to apply powder coatings through clean, properly maintained equipment, you want to apply it in the appropriate environment. And then obviously you want to follow the manufacturer's recommendations for coating thickness and cure parameters. Not all powder coatings are the same. My polyester powder coating may not be the same as my competitor's polyester powder coating. So take a peek at the technical data sheet before you apply the powder. Make sure that you're familiar with what those recommendations and requirements are. As far as applying powder through clean, properly maintained equipment, keep your equipment in good working order. It only makes sense, number one. Number two, if you're changing colors a lot and you're using a variety of colors, try and have dedicated hoses for color groups, if you will. That will help cut down on some of the contamination issues. And then a word about the environment. I've seen a number of different environments that are less than safe. You have an electric charge that's being applied to powder coating, you have a grounded circuit, and then you have this cloud of powder coating that's floating around. Guess what? It's an explosion hazard. It doesn't happen very often, but it is something to think about. So if you have a part that is poorly grounded, and now you've got an electrical charge, and you're hearing pop, 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 guess what? It doesn't happen very often, but it's an explosion hazard. You've got an arc, which is your source for ignition. You have the powder cloud, which is basically encapsulating oxygen, and it's flammable. It's not flammable as you hold it in your hand, but if you throw it up in the air like this and hit it with a lighter, guess what? It's going to go poof. So do take care when you're make sure your environment is the right environment to be applying powder coating. Take some cautions. Make sure that it's in the right order. It's already an efficient process. There's no reason to cut corners. If you want to make sure that you're going to get the prescribed mechanical performance and the appearance that you're looking for powder coating, you've got to get it cured. So you get a technical data sheet in, and it says, I don't know, 7 to 10 minutes at 400 degrees. What does that mean? Does that mean apply my powder coating, put it in the oven, close the door, set my timer for 8 minutes, open the door, pull the part out, and I'm cured?
No.
No, that's metal at temperature. That's metal at temperature. So depending on the substrate and the component that you're powder coating, it's going to take some time to get that product up to temp. So for example, if you're coating aluminum railing, well, maybe you can get that part up to temp in 20 to 25 minutes. On the other hand, if you're coating a car chassis, an old classic car chassis, it might be 45 minutes. So, on your data sheet, you're going to see two things, time and temperature. Again, make sure you understand it's substrate temperature for the prescribed time. This is a data pack oven profile or oven recording. Any of you had that done? Do you do that in your own shops? You've seen it? Know what it is? It's a lot of times, just so that you're aware, a lot of times either your oven manufacturer or your gun manufacturer or your powder manufacturer, they can provide that service for you, just to record your oven, just to see what your oven is doing. This oven is, it's not perfect, but it's a good example for what we're talking about. In essence, what you do is you take this device, you have several different probes, you can attach the probes to different parts of the oven, different thicknesses of parts, and then obviously you can record the air sample. So you can see this very top line here, that is your air temperature. You can see where the oven is cycling on and off. So the PLC is being told, okay, I'm too cold, you need to turn the burners on. It turns the burners on, it reaches the max temp. The PLC says, okay, you've reached temperature, turn off. And so it's turning on and off, on and off, on and off. The blue, red, and green lines you can see here, those would have been probes that would have been put on the part itself, and you can see that different components of the part, depending on how thick the metal is, or where that part was in relation to the burners of the oven, it may or may not heat up quicker or slower compared to the next. In essence, if we were to tell this particular customer, okay, 15 minutes substrate at temperature for 400 degrees, we would be able to quite literally, we would be able to tune his entire process for that specific part to make sure that we got that product completely cured. Okay, so it's just my recommendation, what I typically recommend to my customers, certainly once a year have your oven recorded just as a matter of preventative maintenance, but as you do maintenance on your oven, you do want to have it, you do want to make sure that it's functioning properly, so it's not a bad idea then. If you want to plug it into a quarterly preventative maintenance program, that'll work for you too. These systems, there are a number of ways to get this data. The data pack system, I think, Chris helped me out, I think it's about $3,000 for a system. So it's not super expensive. If you do a lot of powder coating, it's probably worth it. If you have a customer that comes in and says, give me the assurance that I'm looking for, that you followed every possible quality measure that you can, the first thing that I would pull out in that instance would be my pre-treatment logbook. The second thing that I would pull out would be my oven recordings, and I would say, here's what we're doing. Here's how I know. Speaking about quality assurance, once you apply the powder coating, obviously you want to do some tests to make sure that powder is going to perform as you would expect, or as you're promising your customer. Some of these are destructive tests, so obviously you don't want to do it on a finished part. At least, excuse me, at least the component of a part that your customer is going to see. But if you can get the underside of a bracket, or maybe hang a sample piece alongside the part that you can do your testing on, it's a good idea. Thank you, sir. Thank you, Keith. So with mechanical properties, you want to take a look at flexibility, adhesion, your chemical resistance, and then with a visual inspection, obviously you want to make sure that you've got good coverage. Number one, you want to make sure that the powder coating looks like what you expect. If you're supposed to be applying gloss black and you pull it out of the oven, you go, well, this isn't glossy at all. This is flat. Well, that's happened to me, by the way. I saw the look. I've gotten that telephone call where it was supposed to be a bright glossy orange, and the customer called me up and said, I got orange fine texture. What in the world is going on here? So it does happen. You know, that's a little bit extreme, and it's obvious. But if you're supposed to have high gloss and you get a semi-gloss, well, guess what? You need to take a look at your powder. You need to take a look at your process. Did we miss something in the application of the powder? On the other hand, if it's supposed to be semi-gloss and it comes out and it's 100% glossy, guess what? You got to go back and do a little bit of an investigation. Did I get the coating properly cured? Is the powder coating out of spec? Is the powder coating out of date? All of those questions, you start asking those questions. I can't speak about my competitors as far as Tiger is concerned. If you pull a part out of the oven and it doesn't look like it's supposed to look, in all but a fraction of a percentage point in 10 years that I've worked at Tiger Dry Lac, it's been related to cure. So you put the part in the oven, you counted to 10 minutes, you opened up the oven, you pulled it out, it's heavy steel, it's supposed to be glossy, it's semi-gloss. What's wrong? Well, let's start here. Put it back in the oven, set your timer for 35 minutes, pull the part out of the oven, and let's see what it looks like. In most cases, they pull the part out of the oven and they go, that's it. So it's worth taking a look at. Some of the quality assurance testing that we would do, depending on the level of the customer or certainly we would do these mechanical tests in-house prior to packaging and delivering powder coating. But larger OEMs will have a variation of these types of tests. They would be film thickness tests. If you're applying powder coating, guess what? First rule of powder coating is get it cured. Second rule of powder coating is get it applied and according to specifications and recommendations. One of the key components to getting the mechanical and the visual performance out of the powder coating is going to be applying it at the right thickness. So if the technical data sheet says, 2.5 to 3.5 mils, and you're at a mil, guess what? You're sacrificing something either in mechanical performance or visual performance. So it's a good idea if you're in the business of powder coating, have a thickness gauge. Cross-cut adhesion, pretty simple adhesion test to do. It tests both cure and the substrate preparation and cleanliness. But in general, it's a cure test. So there are ASTM methods, prescribed methods. Typically, when I'm out in the field, I don't have those tools available to me. So I get a box knife and I get some duct tape and I cut my grid on my part. That's what you're seeing up here. You're seeing some impact testing, but there's some crosshatches in there. So I'm cutting, using a box knife, I'm cutting my grid, I'm putting my duct tape down, and guess what, duct tape, it's not the prescribed ASTM tape, but it's a whole lot more, it's got a whole lot more adhesive properties to it compared to the recommended ASTM tape, okay? So I apply my tape, I remove all the voids, I yank that tape off kind of at a pretty vigorous 90-degree angle. Guess what? If it's secured, I don't remove any squares off of that, it's pretty good. You can feel pretty good about your cure in that case. Boil adhesion. Boil adhesion is an architectural test. Basically, you take a panel, a coated panel, you boil it for 20 minutes, you pull it out, you let it cool down, you cut your crosshatch in, you do the test again. Basically, what that's testing is, obviously, you're boiling the part with the paint. It's absorbing moisture. If you've got poor adhesion, guess what? That moisture is going to lift that paint off the part. So boil adhesion is a pretty good test of the mechanical stability of the coating system as far as its adhesion. Impact resistance. In the laboratory, that's what you're seeing with those little divots and dimples in the part. Impact adhesion. Obviously, you're not going to have that. You're not going to have that available to you in the shop. If you coat a sample part or whatnot, you know what? Take a ball peen hammer to it, just for your own. You can't measure it. There's no quantifiable portion to it. But take a ball peen hammer and go. You know, is it chipping off or chipping off because it's not supposed to? Typically, if it does, you've either got a poorly prepared substrate or the powder coating isn't cured. Again, it's a destructive test. Do it on a sample part, not on your finished good. Chemical resistance, pretty easy. How many of you folks know what a chemical rub test is or an MEK rub test is? Pretty simple. You take a Q-tip into MEK or acetone, and you rub it in a line, in a consistent line, over itself. Once forward and once back is considered a double rub. And you only have to do it for maybe an inch, but you do it right over top of itself. If you get to 25 double rubs and you roll that Q-tip over and you've got limited or no pigment transfer onto that Q-tip, you know you can feel pretty good that coating system is pretty well cured. On the other hand, if you roll that over and you got a whole bunch of pigment on the backside of that Q-tip, or you've rubbed through the coating system and you've now exposed the substrate, that's a really good indication that something went wrong and you didn't get the product completely cured. That's a really easy test for you to do in your shop every day, every time. New part, new customer. It's super easy to do. It takes zero time to do it. And it's a really effective test.
So will that tell you that the coating is not cured enough once you do your rubbing test?
In most cases, yes. In most cases, yes. I've seen it where if you over-cure it, again, it's starting to turn to ash. I've seen where we get some pigment transfer during that portion. You can use acetone. MEK is a little bit harsher, but MEK is harder and harder to find.
MEK is better to use. Yeah.
If
That's what we use.
If it's MEK, you probably feel pretty good with 25 double rubs. With acetone, I'd go to 50.
How many?
50.
Can we go back to the cross-cut adhesion test? I mean,
Sure.
when you pull the tape, I mean, do you accept like one little square coming out or none at all?
Depends on the ASTM standard in general. So if I were to have a portion of a square peel off, it's one test of many or a couple that you should be doing at the end of the line. If I were to have a square or two pull off, I would start doing some investigation. That would be not typical.
Can you describe that test? I mean, I'm sorry about those details, but that's important for me. So you cut like 1 inch by 1 inch, you cut like a grid of what?
Yeah, so the tighter the squares, usually I'll do, I'll cut 10 vertical lines, and then I'll cut 10 horizontal lines. Depending on the size of the square and the specification, like aerospace and defense, on the defense side, they prescribe squares that are somewhere in the neighborhood of 3/16 of an inch. On the automotive side, by contrast, it's about 1/16 of an inch. The tighter your squares are together, the better test that is. So I would recommend, if you want to do just a quick test, get somewhere in the neighborhood of 1/16 inch squares. So you got 100 of them, you yank the tape off. You know, depending on the specification, again, you're allowed to peel off a percentage. But where powder coating is concerned, properly prepared substrate, if you get that coating system cured, I've never seen a square delaminate. Never. Pencil hardness test, it's more of a laboratory test. A lot of us don't have pencil hardness kits in your shop. I would be surprised if anybody did, but what I can tell you, you do have in your shop that would simulate that test. How many of you have a nickel in your pocket? You can do a nickel drag test. Again, these are indications of cure. And I'm the guy here that doesn't have a nickel, so we'll pretend that this quarter is a nickel. But anyways, so a nickel drag test would simulate a pencil hardness test. And essentially, it's a destructive test, so do it on a sample part or a hidden part. Lay that nickel over at a 45-degree angle, and you're going to press down pretty hard, and you're going to try and scrape that coating off. A properly cured, in most cases, and again, these are all indications. If you get passing results all the way through, I feel pretty good about how my powder coating is going to perform. If I fail a number of these tests, I'm going to be scratching my head going, what happened? What went wrong here? How is this product supposed to be performing? But anyways, so you lay that nickel over at a 45-degree angle, you push down fairly hard, and you're trying to scrape that powder coating off. Typically what happens is you get a little bit of a nick that will expose the substrate, and then that nickel will skip up on top, and it's important to use a nickel. That nickel will skip up on top of the paint, and rather than removing the coating or scratching the coating, it'll mar the coating. Okay? On the other hand, if you lay that nickel over and you go and you drag it across and you peel off a ribbon of paint, that's a pretty good indication that you didn't get cured. So if I do my chemical solvent rub test, I get some pigment transfer. I do the nickel drag test. I'm peeling off a ribbon of tape, and I do a crosshatch adhesion test, and I'm pulling off squares. Guess what? I got a pretty good indication that the powder coating is not fully cured. So what do you do in that situation? Test it. Take your sample part, put it back in the oven, leave it in the oven for another 10 minutes, pull it out, rerun the test. If it passes, you've answered your question.
Excuse me.
Yep.
So for those of us who are outsourcing our powder coating, we feel like we've got a product that we weren't satisfied with. I mean, if we show up to the facility with a sample that they did and start doing these tests, that would give us grounds for, filing a complaint or asking for a redo or.
Why? You're going to upset them if you do that right off the gate. Right out the gate. I probably would go in and say, let's talk about your process. We've had some issues. Let's talk about your process. Show me what you're doing. Show me what are your quality assurance steps that you're doing that assure that I'm going to get the performance that I'm expecting, number one. And then number two, show me your records that show me that you're achieving this, for this specific lot of material. Make sense? Mm-hmm. But you're correct. When you start doing those tests and you start seeing bad results, yeah, you do want to get in front of it. Does that answer your question?
Yes, it does.
Not to upset your coder, if you're not sure that you're getting a good quality piece, do a sample piece, don't tell them why you're doing it, include that with the batch of whatever they're coding for you, bring that in-house and test it. That way you haven't upset somebody that might be doing a really good job.
Absolutely, yeah. Absolutely.
But are there any like minimum standard for powder coating in terms of resistance, adhesion, that we can like, because pretty much if we sub out the powder coating and you say, well, I did the test in the house and it failed, the powder coater is going to say, under what standard? I mean, what is your...
Yeah, so there are a number, it depends on the specification, but there are a number of standards that are and it's voluminous. I mean, there's standards upon standards upon standards upon standards. Generally speaking, there are a number of ASTM methods that are required to meet, depending on the industry. Aerospace and defense, for example, they have their own painting specifications that refer back to ASTM standards. And then architectural aluminum, for example, NOMMA has their own set of specifications and standards. Again, they tie back to ASTM standards here in North America. But yeah, there are. My recommendation would be that you look at PCI, the Powder Coating Institute. They produce a textbook, if you will, that kind of goes through different standards and what those standards are and things like that. So I would start there. Otherwise, it's you'll be reading for the rest of your life.
Thank you.
John,
Yes, sir.
NOMMA has produced a NOMMA reference manual on finishing. I believe the standards are in there, so you can take a look at that. We will have some of those in the NOMMA pavilion, so we'll look at that, when the show opens tomorrow. But the NOMMA reference manual on metal finishing, those standards should be in there also. You have that in your office.
So basically, if you take your product to a powder coater and don't specify a standard, you're shit out of luck.
No, I wouldn't say that. I would say if you, what I suggest doing, we all build parts of railings or fencing that goes into the ground for anchoring. That section that's going to be hidden to do these destructive testing on them. And you don't have to do it on every single job, but you should do it on every, couple of batches to make sure your coder is doing the proper job. And the MEK rub and the stripe test and the scratch test, if you pass those 3 tests, you're going to be fine, because that will show them everything.
I would agree with that. Here's cutting to the chase here. Here's what happens. So if you get a powder coating that is properly cured, you're going to get a performance that is a predictable performance as far as the coating itself is concerned. If it is not fully cured, if it is not fully cross-linked, so cross-linking, what is cross-linking? Cross-linking are you're creating these molecular chains. No, I'm not a scientist, but this was described to me, and it's a beautiful description. So you're creating these molecular chains in the coating system during the curing process. Okay, so the longer those chains get, the better the mechanical properties of that coating system are. Okay, that's why cure is so important. You want to make sure that within reason you're completely cross-linked. Okay, the longer the chains are, you get your mechanical properties. It's more chemical resistant. It's more, if it's polyester, it's more resistant to loss of gloss out in the sunlight. It's more flexible, so it's not as easy to damage the coating, or that's what this impact test is looking at as well. So that's why cure is so important. You want to create these nice long molecular chains so you get that predictable and repeatable mechanical performance out of the system that you're expecting.
Your biggest problems that you have as fabricators using job shops as powder coaters, the biggest problem you'll have is either pre-treatment or cure.
Yep.
Those would be your two issues. And with these tests, the EMK rubs, the strike test, and the scratch test, you'll know if your coater is doing a good job. Now, under cure and pre-treatment usually takes about 6 months to show their face. Okay, so that's usually about the window there. So I know when I've had very large jobs, I get to 7 months and I say, oh, good. I'm safe. But so 6 months is normally where it shows its face.
And if you're a coder, by all means, take the star. I'll share with you a quick story. I had a customer down in Alabama that had created some ornamental railings that were set in granite in Milwaukee, Wisconsin, in the fall. Winter comes, salt on the roads. Spring comes, and 100% of the railing was rusting. You know what happened? The coder took these heavy ornamental fence and rail components and said, technical data sheet says 10 minutes at 400 degrees, set the oven for 400 degrees, which may or may not have been operating at 400 degrees because they hadn't run a recording. Close the oven door, counted to 10 minutes, pulled the parts out, packaged the parts, shipped the parts, they go up to Milwaukee, they get installed. How much do you think it cost that railing manufacturer to pull that material out of granite in Milwaukee? It's worthwhile to take the steps, do a little bit of, have somebody at the end of the line that goes, you know what, are we getting to what we said we were going to get to? Are we going to deliver what we promised we deliver to? It's in your interest and it's in your customer's interest. Conical bend testing, the last test. You can see the apparatus down at the very bottom. Basically what it does is it takes an aluminum or a steel panel that's prepared in a laboratory and it bends a radius across that panel, obviously going from quite wide to very narrow. You're not going to have that apparatus in your shop, but if you coat a little panel and it gets to the end of the line, you pull it out, you bend it over, that's a pretty good indication again, because if you got those nice long molecular chains, it's not going to fracture and crack along the end until you just about bend it over on top of itself. And even then, depending on the product chemistry, it may pass that test. So, those are kind of some general ideas. As Keith was saying though, if you're doing the MEK rub, if you're doing a strike test, if you're doing some variety of mechanical test to sort of assure that you're getting the proper mechanical performance out of the equipment, it's in your best interest.
And those 3 tests, what's nice about those 3 tests is they will tell you what the problem is. Is it cure or is it pre-treatment? Because in 6 months from now, when you go to that job site, the customer's complaining it's peeling off, you're not going to know if it's cure or pre-treatment. But if you do that test before you install the fence or railing, when you pick it up from the powder coater or bring it back to your shop waiting to be installed, to do that test, you'll know right then if there's a problem with it. And you'll know what the problem is. And you could go tell your coder, your washers, you need to take care of your washer, or you need to take care of your oven. If you just go to your coder and tell him, the paint's peeling off, what are you going to do about it? He's not going to be able to do anything for you whatsoever, because he's not going to know what the problem is. You have to tell him what the problem is, but he's not out there in the field looking at his product. So if you have a problem with your job and you go to him and say, look, it's not cured, check your ovens out. Your ovens aren't working properly. That coder, instead of getting mad at you, will be your friend for life because you just saved his business.
So let me ask you a question. So, the MAK rep will indicate
The cure,
curing,
Yeah.
and then the clinical testing will be
pre-treatment.
pre-treatment.
It would be curing too, though, but it's more for pre-treatment.
The best test for pretreatment would be to find a laboratory that would do some neutral salt fog testing if it's iron. So, depending on who your coating supplier is or your pretreatment supplier is, they offer those services.
And if you wanted to set up your own testing facility with salt spray, talk to Amos Glick from Compass Ironworks. He set up his own in his shop.
And you can do that.
Very simple salt spray, pump, some nozzles. Yeah, very simple, he put together.
You can do that. So moving on, unique applications. Obviously, powder coating is growing as a more widely used technology, but there are occasions where you'll be asked to use a unique application, something that might be a little bit unfamiliar to you or a little bit unknown to you. So some of those examples would be multiple powder coating layers. It's not so unusual if you have a primer and a top coat, but what if you have a primer, a top coat, and then a clear? Powder coating and liquid paints. So for example, aerospace and defense, there are a number of specifications that start off with a powder coating base, and then there's a liquid top coat that's applied to it. How does that work? There are aluminum, cast aluminum wheels, automotive wheels that you would buy on your new Toyota or your new Honda or whatnot. Those coating systems, believe it or not, in most cases in North America, it's going to be a powder primer, a liquid color coat, so your liquid color, and then a clear powder top coat. So it's actually a 3-layer system with liquid in the middle. And then there's a variety of substrates that you can powder coat: wood, glass, and other composites. So multiple layer applications, obviously, they're becoming more common. So let's keep in mind, follow the manufacturer's recommendations. Don't mix vendors' powder coatings. It doesn't happen very often, but my polyester may not be compatible with my competitor's polyester. So if you're going to use a 2-layer system, and then I'm going to give you the other scenario. What happens if there's an issue? Which coating manufacturer do you call? If you use my competitors as a primer and you use me as a top coat, who are you going to call if there's an issue? You're going to blame the... hey, they're not sticking together. Are you calling the primer supplier, or are you calling the top coat provider? So make sure you don't mix vendors. The way the system works is pretty simple. You partially cure the first layer or first 2 layers. You partially cure them, and then you apply your top coat, and then you fully cure the system as a whole with your final cycle in the oven. So top coating epoxy-based products with an exterior polyester, clear, translucent. This is a big misnomer within the fence and railing industry in general. If you have a hybrid vein product, for example, a copper vein, a silver vein, a gold vein, whatever the case may be, and it's a hybrid, there's an epoxy component to them. Epoxies are they're not durable. You can't put them out in the sunlight. They're going to chalk. The misnomer in the industry is that, well, that's easy to solve. I'll just put a clear polyester or super durable polyester top coat over the top of it, and everything's going to be just fine. That's a misnomer. What will happen is eventually it will chalk. The epoxies will begin to break down. It'll chalk between the layers, and now your clear coat's going to come off in a sheet. So if sunlight's going to hit the surface, if you can see the surface and sunlight's going to hit it, make sure that it's properly durable for that environment.
So when do you use epoxy?
Epoxies are great for interior applications. They're great where you need chemical resistance. They work fantastic as a primer. There are a number of reasons and applications you can use epoxy or epoxy hybrids. The trick is you just don't want to put them outdoors.
So did I misunderstand you by saying that if you use an epoxy and you put a top coat over it, it's fine?
Yes, as long as it's not clear or translucent. Yep.
Thank you.
Yep. So one of the unique applications that I was asked to talk about that we're starting to see more and more in industry, Keith had mentioned thermal metallization in a conversation that we had had. What's interesting is I work with the United States Navy, and the United States Navy is now beginning to specify thermal metallization. So you're going to start to see a little bit more of it here and there in unique applications. Basically what the process is you take, in most cases it's zinc or aluminum, you're heating that up to a molten state, and then I think it's 2,000 or 3,000 PSM. It's quite a high velocity. You're taking that molten metal and you're causing a collision between it. You're applying it to the top. You're smashing it into the top of the substrate then, your original substrate. So for example, fence and railing, you may be able to, the bridge manufacturer, for example, he's got a 40-foot girder. He can't exactly get that into a galvanizing tank. He's going to use zinc metallization to put a sacrificial zinc layer, apply a sacrificial zinc layer to that steel girder. So that's what that process is, and so the question is, can you powder coat that? And the answer is yes, you can. You just need to you need to take some steps, just like you would with galvanizing. You need to take some steps to make sure that you don't have an outgassing issue. But that's really the only issue between metallization, a metallized substrate, compared to a normal substrate. So the application of, and I'm going to read this one verbatim because I'm not particularly familiar with it, but the application of a mechanically bonded dissimilar metal on top of another original fabricated substrate is typically zinc or aluminum. Aluminum oxidizes slower than a ferrous substrate, so that's why the attraction to aluminum. It corrodes differently. And then zinc acts as a sacrificial barrier. So the example I just gave you is a perfect example of why would somebody use zinc metallization to protect a girder or a mechanical component, a large mechanical component. So you metallize these ferrous substrates. It primarily adds a protective moisture barrier, and it reduces the potential or slows down corrosion. The application of powder coating adds an additional barrier protecting the metal from corrosion. So this conclusion, I actually wrote this page the other night, and I underlined and highlighted a couple of key words, a couple of key thoughts. So the application of powder coating serves as a pleasing, it's decorative coating that enhances the visual appearance of fabricated components. The functional component, however, it helps to protect the substrate from corrosion and decay. So there's two reasons that people would select powder coating. It's a decorative coating and it's a functional coating. If you want predictable results, repeatable and predictable rights, you've got to take care. You've got to carefully apply the powder coatings, and then after the powder coatings are applied, you've got to be sure you've got to give some assurances both to yourself and your customer. You do those things, you're happy and your customer's happy. Questions? I spit out a lot there. Let's start over here. Yes, sir.
Earlier, when you were talking about the multiple layers, you said partial cure of the first and second layers. Are you talking about taking it all the way to flow out or prior to flow out?
No, you want it to flow out.
So taking the first two layers to flow. Then
Yeah, so if it's a 3-layer system and you've got, you know, a primer and then a color coat, and you're going to put a clear on top as your final coat, you would want to gel those first 2 coats out. So basically, if you figure, all right, this thickness of metal, I usually put this in the oven for 30 minutes, and I know that I'm going to get fully cured. Basically, what I would do is I would cut that down in half. So I'd go, okay, I'm going to apply my first layer, I'm going to put it in the oven for 15 or 20 minutes, I'm going to pull that out, let it cool down, put the second layer on, back in the oven for 15 or 20 minutes, pull it out, let it cool down, apply my final layer into the oven. Now we know, okay, it's going to take 30 minutes in my oven to get this substrate cured at this temperature. You're going to run it for the whole 30 minutes at that point in time, and then it cures that system as a whole. In general, it's not problematic if you fully cure the base layer, but there are a handful of instances where polyesters won't bond to a fully cured epoxy. If you're applying clear to a metallic coating, too much of the metallic component sort of comes to the surface, and so you get very poor adhesion in those instances. Those are the very rare instances where you need to be a little bit careful about making sure we're not fully curing that first coat. You're welcome for that, by the way. I could see the reaction was really remarkable.
It didn't make me happy.
Yeah. We can talk about it a little bit later if you want.
Well, obviously, the best thing would be run some tests first.
Yeah.
Tests.
You can bet your sweet ass on it.
Yes,
What
sir.
happens at the end of the life of a powder coated product, a railing or a fence, whether it's 10 years or 15 years? How do you recoat? How do you treat that?
Sure, honey.
Paint over it?
Sure. Look, your best results are going to come from a bare metal substrate. So it's not that you can't recoat. I wouldn't advise it after it's left your shop.
So would paint be a better solution than powder on a 10-year situation?
Say that again.
I'm being a little controversial here, but wouldn't paint be a better solution on a railing than powder coated in 10 years?
No, I mean, look, paint and powder coating, liquid paint has, there are certain advantages to liquid paint and there are certain advantages to powder coating. So, liquid paint in general, and this is a generalization, this is not every case, but in general, liquid paint does not adhere to the substrate like powder coat does. So, powder coating after 5 or 10 years in Florida may have shifted in color. It may have faded or chalked a little bit. Liquid paint would likely be completely rubbed off.
Can I answer this?
Not in every case, but in most cases.
Okay. I've been dealing with powder coating now for approximately 30 years. So there's jobs that I've done 30 years ago that I've gone back to. And if the powder is not peeling off and the powder is still adhered and just faded, the customer could paint over that themselves with a liquid paint. If it's peeling, then most times with the masonry work, 'cause I do railings, most times the masonry work don't last as long as the railings do. So when the masonry work is redone, the railings are removed, I bring them back to my shop, sandblast them, right, so I have a fresh surface, powder them again, because remember, you're powdering pre-treatment, you're not powdering the substrate. So we powder them again, put the railing back in again for the customer, and they look like brand new railings again. So if you have an aluminum railing or a steel railing, the best thing to do is to remove them, bring them back, sandblast them, repowder them, put them back in again. So that's touching something up in the field after it's been there for 10 years, to do a touch-up, it really doesn't work well. You need to remove it, sandblast it, repaint it. But I have lots of railings out there that are, I did railings 40 years ago, and they were anodized. They were aluminum railings anodized, silver, gold, whatever. Taking those railings, sandblasted them, powder coated them, put them back in again, it looked like brand new. It's a 40-year-old railing.
So the two primary advantages to powder coating, the one is a given. It's considerably more environmentally friendly to apply powder coating as opposed to liquid, and it's more efficient for you as an applicator. The second component is, in general, and this is a generalization, I'm not trying to oversell powder coating, but in general, in most situations, powder coating has better mechanical properties than a liquid system that's applied. So one is a chemical cross-link, the other is is cross-linking in the oven, and for whatever reason, generally speaking, powder coating is a pretty tough coating system. So,
When I put my paint line in, I put my paint line in about 17 years ago. That I've been an in-house powder coater. And the reason I went to that is in New Jersey with the environmental laws, they were requiring me to put in a spray booth. So I had to put in an automotive spray booth, right, to do liquid paint on an aluminum railing, which doesn't work very well. So it was easier for me to put in a powder coat system because now the environmental issues are non-existent. I don't get the EPA doesn't come into my shop anymore because the powder coating is so environmentally friendly. And it was really one of the best things I could have done. I'd also like to add something we didn't touch upon. What I want everyone to realize is in the cold environment where you're dealing with calcium chloride, rock salts, ice melts, polyester powders don't hold up to that. Your clients need to know that if they use rock salt, it's going to deteriorate that finish on that railing or fence. The only thing that stands up to the chemicals is the epoxy, and they don't stand up to the sun.
yeah, so there's a great remedy for that, and I'd like to talk a little bit about it. So if you use an epoxy, if you use a two-layer system in those environments, an epoxy primer, and then let's say a semi-gloss black polyester over the top of that, what you're doing is you're doing two things. One, we mentioned earlier, powder coatings are semi-permeable, so they wick moisture and oxygen back and forth through the paint. It's not very great, but there are pores in that coating system. So if you have a primer base layer that's epoxy, now you're going to get your chemical mechanical properties. You're going to put a polyester over the top of it where you're going to get your weatherability from. It's going to hold up better in the sunlight. But guess what else you do? You have a different pore structure. So you're doing a better job of encapsulating the substrate, and you're removing some of the likelihood that moisture and oxygen is going to permeate through that coating system. So it's a good method in challenging environments to elongate the life of your product. Yes, sir.
In experience with coating over like galvanized, fencing, rail, what would you recommend? Like, you can just coat over that, or anything you do special?
Well, I would recommend a sweep blast without knowing it. It depends on the quality of the galvanized. I would recommend a sweep blast, first of all. Secondly, you're going to have to outgas that product. And I would probably use either an outgassing forgiving primer as a base layer, and then top coat it with your color, or maybe consider an outgas forgiving top coat, and maybe coat it while it was still a little bit more. Again, it depends on the quality of the galvanizer. That's a big question.
We have time for one more.
Yes, sir.
As a company, we prefer using powder coat for our rail systems, but we invariably get a call from the field crews. They had field modification, there's damage, and now we've reached the coating. Other than a custom mixed paint, which is a Band-Aid, is there any way to repair the powder coat finish in the field?
Sure, it is. It is in some ways. It's a Band-Aid. Is it as good as it's going to be out of your shop? No, but it is. You can touch up powder coat. So you can. My recommendation, just like you would with an automotive
That's what
repair.
we're doing now.
Yeah, you're gonna clean the substrate. You're gonna prepare the substrate for paint as best as you can. Maybe you're gonna use a 2-layer system and you're gonna follow that.
If you have a custom color that you can't find a touch-up for, you could always take some of the powder and mix it with a solvent. And if it's just a little scratch or something, you could put it on with a brush.
Well, our powder coater uses your product, and he will custom mix a color to match and give it to us in aerosol cans.
Yes.
Yeah,
That's about as close as we can get.
Yeah, that's available in one. The other thing that you can do is you can go to, it's been a while since I've seen them, but like you can buy like the baby food jars with the aerosol CO2 cartridges attached to them. Yeah, you can find those, and then go. I would actually go to like an automotive liquid paint store and say, hey, match this for me, and I only need a quarter. You know, and that will save you some time and expense.
All right, well, thanks everyone for coming in. I want to thank John for doing this terrific presentation. He will be